I see people coming in. Not really.
I was like, what?
Yeah, I was like, wait, it's us four.
We do have two.
I have my glasses on, but it looks like 4.
Are we the 4?
Good morning, everyone. Thanks for joining us on this, what will be a dry morning, meaning no rain. So that will make our sampling today easier. So thanks everyone for joining. Today is the 4th annual, actually we were thinking it might be the 5th annual, but besides the 4th annual Sea Level Solutions Day. And so my name is Tiffany Troxler. I'm the Director of Science of the Sea Level Solutions Center in the Institute of the Environment at FIU. And I'm joined by Dr. Susan Jacobson, who is a professor in the Department of Journalism and Media in the College of Communications, Architecture, and the Arts. And our program today is sponsored by the Miami-Dade Environmental Education Program. We also have Alyssa and Madi who will be helping with our webinar today. So we're just we're gonna start off with our usual quality of life poll. Hopefully you've had 1 cup of coffee so far. And then we'll do a quick 101 on sea level rising king tides. And then we'll get into the Sea Level Solutions Day training and what we'll be doing and how to use the smartphone application and the citizen science kits you'll be using today as part of the program. So with that, Alyssa, could you please start the quality of life poll?
Definitely. Hi, everyone. Good morning. So you should see a pop-up on your screen with a poll. If you have joined us for other webinars, we ask that you please fill out the polls again. So you should have 6 questions in this poll, and you have to select an answer for each, scroll all the way down, and press submit in order for your answers to be recognized. I'll walk you through the questions. Number 1, I am student or non-student. Number 2, the type of business where I work is private sector, government, nonprofit, self-employed, and I'm not working. Number 3 is a multiple response question, so you can select multiple answers. The question, what are the 3 most important things that determine your quality of life? Health, family and friends, happiness, freedom, learning and education, religion, being outdoors, connecting with nature, work-life balance, safety or security, and good pay or good job. Number 4, what are the 3 most important concerns you have about sea level rise and flooding? This is also a multiple response question. So we have applying science to make good decisions to address these issues, increasing threat from storm surge, impacts to property value, impacts on community, family, and friends, lack of awareness and no action to address it, impacts to wildlife and natural habitats, exacerbation of social inequities, relocation, water contamination and public health impacts, and impacts to infrastructure. Number 5 is, what are the 3 most important concerns you have about other impacts of climate change? So increasing heat, more intense storms, applying science to make good decisions, impacts to property or property value, impacts on community, family, and friends, impacts to natural habitats and wildlife, impacts on public health, increasing threat from storm surge, lack of awareness and no action to address it, and exacerbation of social inequities. And the last question, what do you think are the 3 highest priority initiatives or actions that can be done to reduce the impacts of climate change as well as improve your quality of life? We have increased use of renewable energy, use small bonds or small increases to reduce greenhouse gas emissions and finance projects, increase city and community initiatives that support household activities like composting, eating less meat, and tree planting, elevating buildings and other infrastructure, updating codes, planning, and infrastructure based on the best available science, increase community or city green initiatives like tree planting, vegetating swales, and increased restoration, support low wealth communities, increase community awareness, move to a low risk neighborhood, and improvement of water management. All right, so we have 46%. We'll give you just about 30 more seconds so we can maybe hit 75 or 80% of our participants. Awesome, we already got to 80. Anyone else? Awesome, we got 93. I'm gonna end the poll here and share the results with you. Oh, so we have 50-50, half students, half non-students. Most in the private sector, if not working. So the 3 most important things that determine this group's quality of life is health, family, and friends, and a tie with being outdoors with nature and work-life balance. Very important. And so for the 3 most important concerns about sea level rise, we have applying science to make good decisions, as well as lack of awareness and no action to address it. For number 5, the 3 most important concerns they have on other impacts of climate change. So same thing, applying science to make good decisions to address these issues, and lack of awareness, no action to address it, as well as impacts to wildlife, which is we care. Let's see here. Number 6, 3 highest priority initiatives for their impacts to climate change and improved quality of life. Increasing city and community green initiatives. Awesome. All right, I'm going to stop sharing the results. Oh, and increase use of renewable energy. That one's important too.
Thank you, Lisa.
No problem.
Okay, so let's do a little introduction to sea level rise king tides, and we'll talk just a little bit about sea level solutions. Next, please. So climate change, everyone here probably has heard and understands a bit about climate change. We'll just lay the groundwork here, and I think one of the most important graphics that help to illustrate the importance of the impacts of climate change on our planet. So climate change is the increase in the emissions of greenhouse, of heat trapping greenhouse gases that result in a change in our planet's climate. And so what you see here in this graph is you see this blue sort of purpley squiggly line, and it's illustrating that that over the last 450,000 years, we've had a fairly stable concentration of CO2 in the atmosphere. And when I say stable, it's been within the range of those black dashed lines. So with between 180 parts per million carbon dioxide in the atmosphere. So between about 180 and 280. And recently, in the last 50 years or so, we've seen an incredible acceleration in the concentration of carbon dioxide in the atmosphere. And that is the straight line that you see in the most recent history that coincides with human activities that have accelerated the combustion of fossil fuels, taking carbon out of the ground, combusting it and putting that into the ground, or putting it into the air, and as one of the activities that increases carbon dioxide in the atmosphere. We have other greenhouse gases. We won't get into that today, but this is to illustrate that climate change is real. It is happening. What we're seeing now is unprecedented in comparison to concentrations that we've seen over the last 500,000 years, and the concentration continues to go up. Right here, I have each year I teach a class in the spring, and I have to update the number here. I haven't done it for January 2020 yet, but each time I present this slide each year, I have to increase the value the concentration of carbon dioxide that we see in the atmosphere. And that comes from measured data that's from a tower that collects carbon dioxide information from the air in Hawaii. And that's what you see in that inset there, is measured carbon dioxide concentration in the air. Next, please. And so as the carbon dioxide and other greenhouse gases, as the concentration of those gases increases in the atmosphere, we get more trapping of heat within our atmosphere. So these greenhouse gases are a natural part of our atmosphere, but when we increase them, they become a pollutant. They trap more heat in our atmosphere, and so that heat's got to go somewhere. A lot of it goes into the oceans. About 90% of that heat is absorbed by our oceans. And that trapping of heat in the oceans is one of the contributors to sea level change. So as the ocean heat goes up, sea level also goes up as the oceans expand, as they trap more heat. And that is one contributor to the change in sea level. Let's talk about some of the other ones. Next, please. Yeah, thanks. So global sea level change. So I talked about thermal expansion. So this is heat being absorbed by oceans, causing the oceans to expand. We also have meltwater. That's another large contributor to sea level. This is melting of glaciers and land ice in Greenland and Antarctica. And that contributes roughly to another sort of large proportion comparable to that of thermal expansion. And then also land water storage when we get changes in runoff, and storage of water in the terrestrial environment. And that can also contribute to changes in sea level. And that's a smaller fraction, but we also have what we observe as regional sea level. So this is the relative rate of sea level change. And this is the sea level that we observe here in southeastern Florida. And that change is that the rate of change is higher locally than it is globally. And some of those drivers are ice mass. So as an ice mass gets smaller or larger, it changes its gravitational impact on local oceans, and that causes a redistribution of ocean levels in other places. Ocean circulation, so this is related to the Gulf Stream. If our Gulf Stream is faster or slower, that has an influence on our local sea levels. And then vertical land movement. So if our land is higher or lower, relative to the sea level, that has an influence on the sea level that we observe. So for example, in coastal Louisiana, we have a significant drop in the land elevation from coastal management activities there. So their relative sea level is higher than what we experience here. We do have some incidents of land, land elevation dropping. We see this more in places like the Everglades, but we have some localized effects of that here in Miami too. Next, please. But very isolated, very isolated. So this is a graphic of on the left there, you see measured sea level at Key West over the last 100 years. And that trend corresponds to the more recent data that have been collected at a Miami Beach tidal gauge. And the measured rate of sea level locally has been about 9 inches of change increase over the last 100 years. And then on the right here, you see sea level rise projections. And so those different curves that you see, those different lines, refer to the different socioeconomic and conditions and human activities that we decide to take or not undertake. So to try to rein in the climate change impacts. So reining in carbon dioxide and other greenhouse gases that contribute to to climate change and contribute to sea level change. So that very extreme one. So one, I would like to say that the farther out into the future that you try to project sea level, the much less certain you are, or you can be, about what that sea level change will look like. But these are modeled projections based on the amount of heat trapping gases, and how much heat we're building up in the atmosphere directly corresponds to the projected sea level that we may see into the future. So the NOAA extreme curve is if we don't do anything to try to rein in our carbon dioxide and other greenhouse gas emissions, nor try to pull carbon dioxide and other greenhouse gases out of the atmosphere. And then the NOAA intermediate high is sort of, you know, what we're on the trend for right now, at least in the near term. And so this kind of graphic is also very useful for planning. We have a 4-county compact. It's called the Southeast Florida Regional Climate Change Compact. And so our 4 counties have come together to develop a consensus on what these sea level rise projections are and what the near-term planning horizons should be if we want to protect our infrastructure. If you want your infrastructure to last for 50 years and not be affected by sea level change, then you may choose a higher curve to protect your infrastructure or whatever project or community that you're planning for in the future. Next, please. So king tide. So I've talked about the sea level change. So now we also have the influence of some variation in tidal activity that happens over the year. And right now in the fall and September, October, and November is when we see what are called king tides. And this is when the force of the earth and the sun, or sorry, the earth and the moon have the greatest gravitational pull on our Earth's ocean levels. And this has an influence on the type of tidal variation that we see. Also in South Florida, we have these semi-diurnal tides. And so sometimes, and one of those tides is usually a little bit higher than the other, and that will be one of the tides that we see today. I think the later tide is roughly about the same, will be roughly about the same height as what we see earlier this morning. But in any case, the king tide can contribute to about 2 feet above the mean tides that we observe. I checked the tide today, so it should be about I think it was about 2.5 feet above our mean tide. Next, please. And so the king tide event, because the water levels are higher than what we usually observe, and you know, in some of our neighborhoods were built before we understood that sea level change was an issue, and that you know, tidal variation on top of that sea level could potentially contribute to flooding in our neighborhoods. Now in some places we see streets and even in some neighborhoods where if we have higher high tides and we also have contributions from rainfall and wind, we can have a condition where you know, the front yard may be dry, and then just a few hours later we might observe some flooding, as we see in the next slide. Next, please. And so, we introduced the sea level rise projections, and I talked about tidal flooding. So as the sea level continues to go up, we're expected to see a greater number of these tidal flood events over time. And depending on what our sea level rise projections look like, will determine the number of these tidal events that we observe in the future. And of course, it depends on the elevation of the land and what kind of adaptation actions that we've taken to try to reduce the risks of flooding. but this gives you an idea that if we, as the sea level continues to rise, and depending on what sort of actions we try to take to minimize the larger curves of sea level in the future, will determine how many tidal flood events we get into the future. Next, please. And so we know that the impacts of sea level rise are already here. We showed you a picture from Fort Lauderdale, where we've seen some tidal flooding events, or some tidal events influence flooding in neighborhoods. We also see that around Miami and some of our lower lying areas along the shoreline and along waterways. And because our infrastructure was built, as I mentioned before, we really had a handle on that our environment is changing. You know, we've also built other features of our infrastructure, and that have now made that infrastructure more vulnerable than what we understood. And one of those things is our water management infrastructure. A lot of our water management infrastructure is based on gravity flow, just trying to move water from the land through canals, just based on the difference in elevation between the land and the sea. And if our sea level goes up, that reduces the capacity for that gravity flow, and therefore we can see more localized flood events when the infrastructure is not working as well as it was designed to work. We also have things like increasing groundwater table, that in some areas where septic systems were built around parcels that are lower elevation, we know that some of those septic systems are beginning to fail as a result of that. It's a small fraction of those septic systems out there, but it's something we need to take a much harder look at in terms of understanding the influence that can have on our water quality. And then also saltwater intrusion, as the sea pushes harder on our freshwater aquifer. And if we don't have enough fresh water that's recharging the aquifer, that can push the saltwater wedge further inland, which can have an influence on our availability of drinking water. We can move our well fields farther inland, but there are also some consequences of that. So a number of things that counties and cities and states and the federal government are working hard to try to get a handle on, so we can reduce these vulnerabilities. Next, please. Yeah, and so, you know, I mentioned a couple of sources of flooding, and so this graphic illustrates that, you know, we can have a couple of additional sources of flooding that can result in what we call compound flooding, which is a threat multiplier, meaning that the risk of flooding becomes higher. So we talked about sea level rise. We talked about the tidal variation on top of that, rising groundwater levels, you know, with the, you know, seasonal change in rainfall. We have higher groundwater levels in the summertime and into the fall. They're lower in the dry season. Then you have the influence of storm tides and waves. Then, you know, we've seen these amazing rainfall events. So if the groundwater table is high, and, you know, you have a significant rainfall event, there's nowhere for the rainwater to be stored because the groundwater is very close to the surface, and that can result in flooding inland. And then if we have a lot of water coming down the canals, because let's say we get a lot of rain in Lake Okeechobee or in the Everglades, all of those different sources, water sources, can add together, which can result in a greater risk of flooding in certain locations. Next, please. And so this is a image that was shot from a drone in 2017. This is one of the sampling sites that we frequently, or that we visit every year. And this was shot by Dr. Jacobson's student, Colin Simpson. And so this is an example of compound flooding, in that we just had we had just had Hurricane Irma. We had a lot of, our groundwater levels were quite high during that period of time. And in this instance, we saw flooding in some locations, I think, 1.5 feet above the ground surface. Next, please. Okay, so let's just really briefly some of the types of sea level rise solutions. So we have mitigation, which I talked a little bit, reining in our carbon dioxide and other greenhouse gas emissions so that we can reduce the causes of climate change. So this can be any type of anthropogenic or human intervention to try to reduce the emissions of those greenhouse gases or sequester more of those greenhouse gases. And restoring mangrove forests is one way that we can sequester or get more of the carbon dioxide out of the atmosphere and get it below ground where it used to be. And then adaptation. So this is reducing the effects of climate change. So elevating homes, moving our, lower lying, trying to protect our lower lying areas from future development. So different kinds of things that you can do to adjust the environment to reduce the flood risk. That is adaptation. Next, please. And so so Miami-Dade County has been working hard on a sea level rise strategy to look at adaptation options and worked closely with the community, invited people to provide input on sort of the earlier ideas about what these kinds of strategies could look like. And this I think will come out in a report very soon, so you'll be seeing more about this, but it's just to give sort of an idea and some, through visuals and some, nice analyses that I think will also be released along with the report about some of the adaptation strategies that can be used. And in several of these cases, they also offer mitigation solutions. So if you're increasing the amount of natural areas, the amount of wetlands, particularly mangrove wetlands, as you're adapting the environment, you can also mitigate the causes of climate change by sequestering more carbon dioxide and getting it below ground, or building near transit corridors that can encourage the use of public transportation, and thereby reducing the emissions of carbon dioxide from the vehicles on the ground. So nice renderings, and we'll be seeing more of this in the future, so stay tuned. But just an example of some of the types of adaptation strategies that we can consider. Next, please. Okay, so thank you for your attention, and now we're going to go into the How Did We Do poll. Take it away, Alyssa.
Awesome. So we have another poll pop-up. This is a shorter poll. It is not graded for those of you that are students. So I will give you a few minutes to do this, and I will walk you through again. Number one, what causes global average sea level to rise? So we have excessive heat in the oceans caused by warming, melting of land ice in Greenland and Antarctica, melting of glaciers around the world, and all of the above. Number two, the rate of rising sea level in the vicinity of Miami-Dade is different from the global averages. Why? We have redistribution of land-based ice causes Earth's gravitational field to change. We have changing ocean currents such as the Gulf Stream, or all of the above. Number three, flooding in coastal areas of Miami-Dade County may be caused by blocked local drainage, inability of canals to discharge local floodwaters, rising groundwater levels, rising sea levels. Rising sea levels is there again, sorry about that. And all of the above. And number four, what are the flooding threat multipliers? Sea level rise, increasing rainfall, rising groundwater levels, and all of the above. Awesome. So we have 62%. see if we can get to 80 and then I will end the poll. Oh, yay. All right. I'll see if there's any more stragglers. All right. Ending the poll, sharing the results. So number 1, what causes global average sea level to rise? Correct. All of the above. Number 2, the rate of rising sea level in Miami is different from the global average. Correct. All of the above. Both redistribution of land ice and the changing currents. And number 3, flooding in coastal areas of Miami-Dade County may be caused by, as well as all of the above. Rising sea level twice, double time. And we have, what are the flooding threat multipliers? All of the above as well. Thank you, everyone.
Okay, so what are we going to be doing today? Next, please. All right, so today is, as I mentioned, Sea Level Solutions Day. This is when we come together as a community to get out into the field and document the flooding that we observe. Document the height of the flood, the salinity of the flood, and the quality of the water of the flood. And this is from, that was a picture from Vizcaya. When we did Vizcaya has always been a big supporter of this event, and we used to hold it in the Vizcaya Garage, which is, it's now the Vizcaya Garage, but it used to be the Miami Science Museum down there in the Grove. But in any case, next please. But we will do that again next year, right, Susan? Yeah. All right, so what are we doing today? So we're working together to get out into the field to improve the information about where, when, and what kind of flooding we're going to be seeing, and documenting that information so that we can use it for scientific purposes, as well to help to support decision-making about the types of adaptation that we can take in different areas around Miami-Dade County, and have fun together doing it. So we can use this information to help understand, as I mentioned, how we can design effective adaptation strategies. Other uses of the information could be to inform where an early warning flood risk system might be most useful for neighbors. And lots of other potential scientific and science-based management types of uses of this information. Next, please. Oh, there's the Vizcaya photo. Yeah, so just a couple of images from our previous events. Okay, so this is sort of a all-in-one slide of what y'all will be doing today. So Dr. Jacobson is going to talk about some of the tools that we use to identify where to send you, where we expect to see some flooding today. And it's largely based on where low-lying areas are around Miami-Dade County. And it's not to say that you will necessarily see flooding in these areas, because in some areas we've already started to adapt the environment to reduce flood risks. And that is equally important information for us to be capturing today. So if you go to a site and you don't see flooding, please make sure to still, submit measurements, and then you can go to another site. I think we've added some additional options for sites that you could measure if you don't see flooding in the location, the primary location that you've been provided. And then today we're going to teach you how to document information about the flood and in your citizen science kits, and also emailed to you as the specific location where you're going to be going. We've got the station leaders who are, or I guess everyone should have already picked up their citizen science kits, and then participants who will show up to the sites, so everyone knows where they're going this morning. And then you're going to go to the site and collect data on flooding. And these are some of the types of pictures that we'd like you to take out in the field so that we can verify the measurements that and those data that you're entering into the smartphone application. So we've got flood height. This is flood salinity that you'll be taking with a refractometer, and we'll show you a video shortly that runs through all of this. And then flood water quality. So we've got some bottles in there for you to grab a sample of the water so that we can analyze those samples for nutrients, and then a third bottle that you will help to indicate the presence or absence of fecal indicator bacteria. And you'll be taking 2 sets of samples during 2 times in the tide. So you'll go out and take your first sample around 10 a.m. and then you'll wait until 11 and take a second sample. And so this is just a screenshot of the application, almost there, that Dr. Jacobson is going to go over with you today. And this is where you're going to enter the information while you're on site and upload photos and things. And she'll walk you through that shortly. And then finally, once we get all that information, because we're able to collect it through this application, we'll make all of the data available on our website so that you can go back and see what all the citizen scientists collected during our sampling event today. Next, please. So this is an example of some of the maps that are created. We were working on some other types of maps as well, but this gives you an idea of what the information looks like from a particular tidal event. This was in 2017. Yeah, this was that same tidal event where we showed you the drone video. And you can see that the tide height varies from 10 a.m. Through noon. These different colored dots refer to the different flood heights that were taken in different locations. Next, please. We had a lot of samplers out there that day, I think. Okay, so let me turn it over to Dr. Jacobson. Thank you.
All right. Good morning, campers. Are you ready to go out and measure some sea level rise, flooding potentially? All right, good. So I'm going to show you a few things. I'm going to show you a couple of tools we use to determine, one that determines where flooding sometimes takes place, one that we use to determine when it might take place. I'm then going to give you the URL for the tool that you will use today to document the floods. We'll look at a map that has some of the data that we collected from 2017, so you'll see how the data ends up. And then I'll share a video with you on what you're going to be doing, and then we'll go over the application. So all of that. All right, Mari, I'm going to share my screen. You cannot start screen while the other participant is sharing. Thank you. All right. Okay, so I'll give you the URL for this in a sec, but this is the Eyes on the Rise Interactive Sea Level Rise Viewer. It was one of the first interactive sea level rise viewers in South Florida, and we educated a lot of people about the potential impact of sea level rise on their neighborhoods using it. So what we're gonna do, I'm just gonna enter an address here, and I will enter the address of the Biscayne Bay campus of FIU, which is up in North Miami. So let's see, FIU, Biscayne Bay campus. Oh, put us in the middle. Okay, so just put us here. Let me stick us here. Okay, good. So here we are at the Biscayne Bay campus. Tells us that we have an elevation of about 5.88 feet, which is actually pretty good because most of South Florida is at about 3 feet above sea level. So 5 is not bad, but let's see what happens when we add 6 feet of sea level rise. So I'm just going to kind of scoot this little slider down to the number 6, and we'll give it a second to paint. And at 5 feet, we might be, oh no, we seem to be underwater. Oh my goodness. All right. So even though there are some areas of the Biscayne Bay campus that seem to be above water, you would need to like swim or take your canoe or something to get to them. And this is with projected 6 feet of sea level rise if we do not do anything to adapt or mitigate against the sea level rise. Okay, so you can try this out. I'll give you the URL in a minute. So this map helps us determine to kind of find places where we think that flooding may occur on the days when the tides are high, the king tide days. We have another application that allows us to see when this might happen. And so this really works if you live somewhere where when the high tides are, when we have high tides, where you get flooding. So I'm gonna enter the BBC campus again. That's 3000 Northeast, 151 Street. There it is, okay. And what this does is it maps your location to the nearest tidal gauge monitor. And there's about 500 plus around the state of Florida. So it just finds the closest one. And here we're in somewhere in Holliver Park. And if you roll over the date, so today is the 17th, so we can see that the high tide today is projected to be at 10:37 a.m.
At Holliver. At Holliver.
Yes. Yeah. It changes a little bit from location to location. But 10:37 a.m. And 3.1 feet. And again, so this could be useful if you live someplace where you get tidal flooding. If you don't live in a place where it gets tidal flooding, you can still, refer to this, but you probably won't see anything. Okay, so I'm going to give you the QR codes for these two applications if you would like to try them out. I'm going to keep this up here for just a minute. All right. Okay. Okay. So we'll put this in the chat too if you wanna see it, but it's always fun to enter your own address. Okay. So I'm going to show you one more QR code. Oops, sorry. This one. So this is the tool that we use to document flooding today, if any, to take our samples and enter our measurements. So I'm going to show you a little map that shows what we do with the data when we collect it. And then I'm going to show you a video about, that tells you what you're going to do. And then I'll go over the application. So, okay. All right. So now, first I'm going to show you one of the maps from, not that one, this one. So this is from that same day in October 2017. This was one of the readings. And as you can see, the darker that the dots are on the map, the higher the water was. So if I click here, for example, so this shows the data that we collected. So it shows the location, it gives the latitude, longitude, the date and the time. And then we have people we're going to ask you to take photos. So this is the context of the flood. This is kind of a long shot that shows you where the flooding occurs. So here we see it's in a park and there's quite a bit of standing water in the park. Okay. Then we have a picture where we ask you to stick the, Thank you.
Yeah, they're using tape measures, yeah.
Okay, tape measures, all right. So this person has a yardstick, but you'll be using a tape measure. So there will be two people. There will be one person who is doing the measurements, and that person will put on the gloves, they'll do the measurement with the yardstick, they'll do the measurement of the refractometer. The other person is going to be entering the data into their phone on the app. Okay, you don't want the same person doing this. We don't want anybody dropping their phone into the water, right? So two people. So when you do this, we're going to ask the person who's entering the data to put the number that they see into the app, and then we're going to ask you to take a picture of it just so we can verify it. Okay. All right, so let me now show you our video of what you're going to be doing today. Now, I'll say two things about this video. We produced it in 2017, so the data is a little bit off, and we're using a different application. But other than that, everything is the same. All right, so I'm going to play it.
Hi, my name is Brad, Program Manager with the FIU Institute of Water and Environment, and I'm here to help explain in a how-to video how to use the citizen science sampling kits that we provide for king tide flooding events with the Sea Level Solutions Center. So this year's Sea Level Solutions Day is going to be November 4th, 2017, and we're going to be taking citizens out, students, teachers, residents, and FIU scientists and researchers out into local communities to conduct citizen science measurements of king tide flooding. And we're going to be distributing kits that will help provide all of the tools and information that you'll need to conduct the sampling. And we're here to explain how to do that step by step. So the first thing you're going to do is check inside your citizen science kit that we provide for an information packet on how to download the app and register, sign up for the king tide sampling. It will provide a form for you that's going to have all of the information that you're going to need to input, and it will give further instructions. And the first thing that we're going to have you do is go out in teams to different sites that we have located on a map, also inside your kit. And that's going to tell you step by step what you need to do to conduct the sampling. So each citizen science team is going to need at least 2 people, one person to conduct the actual measurements and the other to input the data into the phone through the app and take pictures throughout the process. One collecting the data. The first thing you want to do is put on your gloves. All right, so you want to have your gloves because you are going to be getting wet. You're also definitely going to want to have high boots. Rain boots, rubber boots are best because some of these events can have 2.5 feet of flooding, and so you will get wet, and that's another reason why you want the gloves, because you're going to be using your hands to actually conduct the measurement. So the first tool you're going to be using in your citizen science kit is the tape measure, and you're going to be recording the flood depth. So you're going to take your tape measure and extend it so that the 0 is facing down, and you're going to put it in the centermost part of the flood where it's deepest, and record the depth in inches. And then you're also going to want to have the second person take a photo of that depth close up so that we can see where the water line is and verify that that's how deep the flood is. So the next step is to measure the salinity and see if there is any salt content in the water in the flood. You're going to take your refractometer and your pipette, which is an eyedropper. You're going to stick your pipette into the flood below the surface and squeeze so that you can draw some water in. And then you're going to flip open the lens on the refractometer and drop some of that water onto the tip, close the lens again, and then look through the eyepiece. When you look through the eyepiece, you should see a little gauge, and you're going to look on the right side for parts per thousand salinity. It should be a number somewhere between 0 and 30, 30 being salty bay water and 0 being fresh water. So look for where the dark blue line and the light blue line meet and record that number again between 0 and 30. You also want to take a picture, if you can, with your phone of the reading that the refractometer is getting, and you want to make sure that there is enough light coming through here so that you can see the actual reading in the eyepiece. When you're done, clean off the refractometer with your cloth. Next, you're going to be taking a sample of the flood with a bottle that is included in your citizen science kit. So you want to take your sampling cup and stick it upside down and put it directly into the water so the water is up to your wrist but not going above your glove, into your glove. And then you want to tilt it sideways. We don't want to collect any of the debris and stuff floating at the surface. So you want to stick it below the surface, tilt it sideways, let the bubbles come out, and then tilt it up so that you can then remove it, cap it, and put it back into your citizen science kit. Then also take a photo of the bottle with the label on it that verifies that that's the sample from that place and time. So finally, you want to make sure that you have taken enough photos of the surrounding area so that we get a sense of context, and if we go back to repeat a measurement there, we can find exactly where you sampled from and repeat that measurement and get good information. So you want to look for landmarks that will stand out, a stop sign or a lamppost, and if you can, measure how far away your sampling site was from that location. So you also want to take a close-up shot of the flood as well as a zoomed out photo to give that context and background for where you took the sample. Make sure that you have taken all of the data that the app asks for. If there are any other notes that you want to make about the location or a description of the flood, feel free to do that as well. You can take a short video, but please no more than 2 to 3 seconds if the flood is bubbling or moving, and that will help us get a sense of where it actually is. If it's located near a storm drain, these are places where we want to get information about the flood. And then finally, when you're all done, remove your gloves. And we also have included hand sanitizers so that you can clean up at the end. And then you're all set.
Okay. All right. So now I'm going to go back to my PowerPoint for 1 sec. Play from current slide. So this is the URL of the application. I'm going to paste it into the chat.
And already did.
Oh,
we beat you to it.
Way
oh, you beat us to it.
I had in my paste buffer ready to go. Okay, so I'm going to go over how to use this form. And in case you lose this or whatever, it's written on the URL is written on the instructions that you will receive inside of your kit. Okay, so I'm going to go to the form now. All right, and it is here. Okay, so this is our form. And so when you pull it up, please pull it up at the site where you're taking the measurement. So you're going to enter the name of your group, put the email of the station leader, and the name of the group members if you would like to. We're going to ask what kind of phone you're using because it helps us determine if there's any issues with the application. We can try to troubleshoot it by phone type. You're going to put the date of the data collection and the time. Now this will auto-populate. Okay, just make sure that the time and the date are accurate. The time is very important. Next, usually when you open this application on your phone, it's going to ask permission to get your location. Please say yes if you can, because what that will do, it will automatically give you, it will show you your location right here on the map. If for some reason you don't see your location on this map, you can use this little form area here to enter your location. You can move the little marker around. But if you don't see the map at all for some reason, just type in your location down here. That's very important because we pin a lot of our data to the location where the data is taken. Okay, then one person will be taking the measurements. So that person will don gloves, will go to the an area where the standing water is deep, which is usually going to be over a water source like a drain, and take the water depth measurement using the tape measure. The other person, a separate person, will be using their phone to enter this data. So as the person who has the tape measure takes the data measurement, the depth measurement, enter the number here and record it in inches. We're then going to ask you to take a picture of the depth measurement because we use this to verify. It's sort of a cross-checking technique. We're going to do the same thing with salinity. So the video showed you how to use the refractometer. So if you're the person doing the measurements, take the refractometer out of the kit, use a little pipette, the little eyedropper to put some water on the slide, close it and look through the eyepiece to get the measurement. You're going to call out the measurement to the person entering the data, and you're going to do parts per thousand. So it's going to be between 0 and 30. Then you're going to take a picture, the person who's entering the data, you're going to hold the eye of the refractometer up to your camera on your phone and try to take a picture. Okay, and that again is used for verification. Then we're going to ask you to take a couple of bottle water samples, put the numbers in here, take a picture of your bottles with their numbers so we know what they are. You can also enter a description of the standing water. And also we want you to take a close-up of the standing water. So show us where the water is coming from. It's usually a drain. Also take the context. Where is it? Is it in the middle of the street? Is it in a park? Where is this standing water? So you can also, if you would like, take a short video of the flood, probably no more than 2 or 3 seconds because then the file size gets to be big. And then it takes a little while for it to upload after you hit submit. And then if you see anything, any kind of contaminant like garbage or an oil slick, you can take a picture of that. That's a contaminant of the water. Then if there's anything else you would like us to know, please enter it here. And don't forget to hit the submit button. And when you hit the submit button, make sure you are standing over the site where you took the measurements because that's where it grabs some of the location data. Hit submit. And after it's done uploading, you should see a thank you page. All right, I'm going to stop sharing. Any questions?
If you have any questions, you can put it in the Q&A feature that we have or in our chat. We prefer the Q&A. I'm good on, are we ready for the satisfaction survey or you want to wait for questions?
I guess we can do the satisfaction survey. Ask people type some questions. We can give them some time to do so.
Awesome. So I will be launching our final poll. This one's only 3 questions, and we just want to know how we did today. First question, how would you rate today's webinar? I enjoyed it, high 5. There were some aspects I really liked, but not everything. It was okay, could have been better, terrible, a waste of time, or I prefer not to answer. Number 2, would you like to participate in an upcoming citizen science event? Yes, no, not sure. And number 3, do you plan on implementing one of the activities you learned about today and record it and report using a smartphone device or other device? Yes, no, I plan to implement the activity, but probably will not record it on a smartphone device. So I'll just give you guys a few more minutes or a few more seconds. I don't need that long.
So I am dropping my email just in case anybody has any questions. I'll be glued to my computer for this morning. So if at any point you need any instructions, have any questions, feel free to email me. I know Alyssa and Maria are going to be out in the field this morning. So yeah, we're there.
I still put my email just in case, but I will be doing what you folks are doing, so.
The bottles, Aurora, so if you haven't already picked up your kits, although I think everyone should have picked up the kits.
Yeah, all station leaders should have picked up their kits, I believe.
Right. Well, I don't know why I can't show this, but anyway, the the bottles have, they're labeled with, you know, it says team, sample, time, salinity. So you just want to use, so your station leader picked them up. Oh, that's good. Yeah, thanks.
You have time.
Yeah, so
salinity.
it's not, you need to enter the information from your sampling site, but it provides you with some guidance about what you need to write on the label. And it's team, sample number, sample number, time, and salinity.
Right,
Alyssa,
I'm gonna
do you guys- oh, sorry. I was wondering if you guys have a
Sure.
kit that maybe you guys can like share some of the material.
Yeah. While I get my kit, you can go over the results.
Sounds good. All right, let's go take a look at this poll. So how would you rate today's webinar? 93% of you guys are giving us a high 5, so high back at you. Thank you so much for participating. The second question was, would you like to participate in upcoming citizen science events? Yes, most of you said you'll be joining us, so that's wonderful. And do you plan to try to implement one of these activities? Most of you guys said yes, so thank you so much. I'm going to stop sharing the polls in just a minute.
I took off my virtual background so it could work. So you'll be getting inside your kit that the station leader should have picked up. You'll have the map of the certain location that you're going with the site circled, as well as the instructions in the back. And then we have here the gloves that you'll be using. And then we also have a refractometer. So it's going to be in this little case. And then you have your 2 water sample bottles. So right here. So you'll be writing as a sample number 1 and 2. And then you put your team name on it. Here's the fecal matter tester. And then we have the hand sanitizer and one of the most important things, the tape measure. We also included a pencil and a marker and a phone holder for taking pictures.
For the fecal matter, how much water should they be putting in?
Is that a question?
Yeah, I'm asking that.
Okay.
It has the directions on here.
Yeah, so to use the fecal matter, and we went through some pretty specific details to make sure that that you guys were able to do it. But anyway, you use one of these. Use one of the sample bottles to collect the water, and you pour that water in the fecal matter bottle. And you shake that fecal matter bottle, and then you sample again with your water quality bottle, and then you'll retain that water from the sample that you take in this translucent bottle. And that's what we're analyzed for nutrients. You don't want to just dunk your fecal matter bottle into the floodwater, because the indicator powder that's in the bottle will just, you'll lose it. So you want to pour your sample into that fecal matter bottle rather than use it to sample the water. Does that make sense, Maddie? Did I explain it clearly?
Yeah, you'd rather have us pouring it than necessarily like scooping it, I would say.
Yeah, okay, thanks.
And also the instructions
Are very
talk
clear,
about-
yeah.
they're pretty clear.
Yeah.
Right, so you have the paper instructions, or on the application, on the form that you'll be using, you have a link to instructions at the top, so you can see them digitally.
Yeah, and you can take the fecal matter sample. We recommend to take it on the first tide, in the first tidal sample, but just to document the, we recommend you take it on the first sampling. Thanks for the question, Joanna.
I don't see any more questions coming in, but feel free again to, we are overtime, it's already 7:30. Does anybody have any?
8:30, it's already
8:30.
8:30, right, I'm sorry.
Time change.
So now you
Awesome.
got time to get a little more coffee, maybe grab a donut and get your teams to get organized and get out by 9:30 so that you're ready to take the first sample between 9:45 and 10:15. All right, guys, have a great time. Be safe, and we'll be back in touch after the sampling event. So thanks everyone for participating.
The last thought, don't forget to return your kits by 3 p.m. at the BBC FIU campus.
Yeah, unless you've made other arrangements, right, with Maria, yeah.
All right, thank you so much, everyone.
Thanks, everyone.
Bye, everyone.
Bye.
Okay.